Hello everyone. This is last question of June 23 paper 1, pure paper 1. So over here it was like seen by I guess more than 3000 people, but there are very special two students who actually reported some mistake, and that made me really see this. I'll definitely read their names out over here, and I'm sending my blessings and best wishes for your A levels, because you're not only studying for yourself, but when you are, adding any detail or any, thing that I missed or something, so you are not only helping you, but many other students. So thank you so much. Let me just check your name and I'm going to be calling you here. Okay, so I have both of them over here. I mean, it would be funny to really go through our mistakes, but I mean, that is common. We all are human. It's common to make mistakes. But the most important thing, I really appreciate your efforts, and you are actually the true audience, like true learner over here, isn't it? So, thank you so much once again, Bilal Mustafa and Ali Khan. Okay, so I'm going to be rectifying that as I promised, and I'm going ahead. So just that part, A part, and then I'll be connecting it with the previous video. Okay, so I just have pasted the question over here. Let's get started. So as we can see, we have the particular function fx given to us in the form u over v. That means we are going to be using the quotient rule, correct? So what we have our u is basically 7x e to the power x, and your v is square root of e to the power 3x minus 2. Just to avoid any mistake, this time I'm going to be, differentiating it first and then substituting. We know that when you differentiate that, you're going to be getting v. We basically have to keep our v, then du over dx we have to write, minus we have to keep our u and dv over dx over v squared, correct? This would be f dash x. So let's find out du over dx over here, because over here as well we are going to be using the product rule, right? So for that, just to avoid confusion, 7, say for example, I'm differentiating this first and that one second. So if I differentiate that, so 7 is going to be copied as it is. E to the power x would be e to the power x only, and x is copied as it is. So what I did, I just have differentiated e to the power x, plus this time I'm going to be, this is the second term, so I'm going to be differentiating x. That would be 1, so we've got e to the 7 e to the power x. Now to differentiate this one, we're gonna be getting, what do we get if we differentiate this? So as over here I'm writing, if it's root x, that is actually x to the power half. If you differentiate that, you're going to be getting half x to the power half minus 1. That gives you half x to the power a negative half, right? So this is what we're going to be getting. So it would be half whatever we have, e to the power 3x minus 2 to the power a negative half. But because it's not x, it is something else inside the square root. So if you differentiate that, we're going to be getting 3 e to the power 3x. This is what I missed, or maybe I didn't. I mean 3 e to the power 3x. That x needs to be there at the top, correct? I don't think this was the mistake. It was on the next step. So like we have differentiated both of them, and now we are going to be substituting it there. So v is as it is, du over dx. Let's take du over dx over here. So du over dx is 7x e to the power x plus 7 e to the power x. Now minus, we have to copy u. U is 7x e to the power x, and we have to write that one, dv over dx. That is half, I'll be moving it down, e to the power 3x minus 2, and out there we'll be having 3e to the power 3x. Is that fine? Hope there is no mistake. Now all over, that is divided. This v basically is going to be replaced by the actual v, not this value. So that actual thing was square root of e to the power 3x minus 2 and whole divided by v squared. So v squared would be removing roots. It would be e to the power 3x minus 2. Correct? So we have got e to the power 1 over e to the power 3x, square root of e to the power 3x minus 2, 7x e to the power x plus 7 e to the power x minus 7x e to the power x over 2 e to the power 3x minus 2 times 3 e to the power 3x. Okay, now the next step, where I need to be very careful. Yeah, so if I just 1 over e to the power 3x minus 2, we are going nothing but timesing it by 2 square root of e to the power 3x minus 2. So that would give us it would be giving us 2 e to the power 3x minus 2, and there we will be having 7x e to the power x plus 7 e to the power x minus 7x e to the power x and 3 e to the power 3x. This 3 I missed, right? Okay, because we multiplied, so it would go out, and we're going to be getting this to be having 3 halves and 2 there. So 3 halves, it's the indices, and we are having 2 there. Let me write this indices a bit smaller, so it would be 3 halves, right? Okay, now the next step we're going to be getting is 1 over 2 e to the power 3x minus 2, 3 halves, and there it is like expanding. It's a bracket closing and bracket closing. So that would give us, what shall we do? Shall we take anything common from this particular point? I think we can take something common now. So the common thing is 7 e to the power x. Excuse me. We're going to be taking 7 e to the power x. Okay. Rest, this is going to be copied as it is. 2, let me add curly bracket over here. 2 e to the power 3x minus 2, and there we have x plus 1 minus x, there we have 3 e to the power 3x. Correct? Okay. This curly bracket should not end over here because we have taken the common there, 7x common. So in that case, it's going to be it's going to be here, right? I think so. Yeah. Okay, now the next step, we will be having, copying it as it is, 1 over 2 e to the power 3x minus 2, 3 halves, and there, can we simplify it more, like expanding? I'm moving this 7 e to the power x outside, so we can write it 7 e to the power x, and inside we will be having 2 x e to the power 3x minus 4x plus 2 e to the power 3x minus 4. I'm very careful this time. Right? Okay, so minus 3x e to the power 3x. Perfect. Let me check once again. 2x e to the power 3x. 2 is going to be multiplied like, we can also write it like that 2 there. If I expand, so the inside thing would be minus 4. So it would be easier for me to check. So x, it would be 2x e to the power 3x minus 4x. Then we have 1 timesing with both of them. So exactly the same thing copied. Yeah, that is fine. I think that is correct. Minus da 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 da. Okay, so this is fine. Now the next step. So this would be 7 e to the power x over 2 e to the power 3x minus 2 to the power 3 halves. Can we simplify it more? So 2x e to the power 3x minus 3x e to the power 3x will give us minus thing. It's going to be giving us what? Minus x, sorry. It will give us minus x e to the power 3x plus 2 e to the power 3x minus 4x minus 4. If you simplify it a bit more, like last step, 7 e to the power x over 2 e to the power 3x minus 2, 3 halves. And there, if we take again, like we can take e to the power 3x common. So if we take e to the power 3x, we will be having 2 minus x minus 4x minus 4. Okay, now let's see what we need to prove. So out there at the top, it was something. Let me take the screenshot and compare. So we're going to be placing the screenshot here. So it is 2 e to the power 3x minus 2 to the power. This one is correct. This segment is correct, outside thing. Now inside, e to the power 3x, 2 minus x plus ax plus b. So a is minus 4 and b is minus 4 as well. So this is what we have got. Correct? Thank you so much. Bye-bye. Take care. Wait, it has connection.